Section 11.9 Functions as power series. In the last section, 11.8, we saw that power series are given something like this. Summation n is equal to 0 to infinity c sub n times x minus a raised to the power n. Here a is called the center of the series. And if in any case the series will converge, usually we will have the series in this form that it converges on a piece of the interval, and if I have a in the center, then over here I have a minus r and a plus r. And then we say that interval of convergence is a minus r to a plus r, and the radius of convergence will be this much, a to a plus r. Now, power series have a lot of application in math, in computer science, and in engineering. That's why we learn these here. You will see if you take the differential equation course, you will see the application of power series, because there is a method for solving the differential equation using the power series. In computer science, when scientists have to play with the data, then it's easier to have polynomials rather than complex fractions. And also these polynomials, which are basically which we get from the power series, they can approximate some unknown function. Now let's start by looking at this simple power series. Summation n is equal to 0 to infinity x to the n. When we expand, we get 1 plus x squared plus x cubed plus so on and so on. Now look at it closely, you might be able to recognize that this is a geometric series with the first term equal 1 and the common ratio equals x. Over here, if you have forgotten what the geometric series is, over here I have put that together. Geometric series is something which looks like a plus ar squared plus ar cubed plus dot dot dot. So if you look at these terms, every next term is obtained by multiplying the previous term by r. R is called the common ratio, and the first term in this case is a, and it can be written in a closed form with the summation a r raised to the power n. Now notice here, the power, only r is raised to n power, not a, and you cannot multiply a and r. So for example, if you have 2 times 5 times raised to n, you cannot say this is 10 raised to n. You have to make sure you understand this, or even if there is a parenthesis, it's not going to be 2 times 5 raised to the power n. It is 2 is separate and then multiplied by 5 to that. Now, because the first term is denoted by a here, and we have an a here in the presentation of the power series, so just that those two a's are not equal to each other, not the same thing. here we are talking about. So just make sure that you understand that. Okay, so now we know about the convergence and divergence of the geometric series. So when we have the geometric series with first term A and the common ratio R, and it converges, and when does it converge? When the R is, absolute value of R is less than 1. So when it converges, it has this form. So the series becomes equal to A over 1 minus R. Now, how we get that, that's beyond the scope of the book, so we will just know it. Now, if, of course, then the series diverges and absolute value of R is greater than or equal to 1. So now, look here. This is something which we are thinking about power series. This is what we call the open form. This is the closed form. But now also, because it's a geometric series, and if it is converging, if it lies in the interval negative 1 to 1, then we can call it a function. So in other words, we have a function f of x which is equal to 1 over 1 minus x, and its power series representation is this one. So we have function one over 1 minus x, which is equal to summation x to the n and goes from 0 to infinity. This is the power series representation of 1 over 1 minus x. Okay, now that we have learned or we have understood what it means to be a series representation, we will notice that just remember this is example. So all the other examples that we will do here in this section are based upon this one example. And this is the geometric series, simple geometric series. So we can now find a power series for any function that can be written in the form a over 1 minus r. So a is the first term and r is the common ratio. So let's look at first example here. We have to find the power series for the function. So we have a is equal to 1. So we have 1 here. And then at the bottom, I can actually write it first. Okay, let's first rewrite this. This can be written as so notice here 1 over 1. We want the minus here. So what will happen? This will become negative x. 1 minus negative x. That's what is at the bottom. So which gives you a is 1 and r is negative x. So now you can obtain the power series expansion of this function, which is 1 over 1 plus x, by replacing the x in the expansion of 1 minus 1 over x. We again write that minus x. This is equal to 1 plus x squared plus x cubed plus dot dot dot. So in that one, we will replace x by negative x. So we get so 1, and then x, I plug in negative x, so it gives me 1 minus x. Then I plug in the x squared, so negative x, and so squared gives me positive x squared plus x squared. Then when I plug it in in x cube, negative x whole cube will be negative x cube. So notice here we are getting the same terms, but the signs are now alternating. Next will be negative or minus x to the 5. Then next will be positive dot dot dot. So this is the expansion of it, but now we want to write it in compact form with the summation sign. So this guy can write as summation n is equal to 0 to infinity. So this will still stay 0 and into infinity because we didn't do anything to go down a degree or up a degree. If we go down a degree or up a degree, then their n stars could change. Inside now, what is the difference now? The only difference is from the above is that we have a negative 1 raised to the power n. Now we have to be, and then x to the n is already there, so that will just stay. Now we have to be careful and check that the power on the negative 1 is correct, because the first value for n is 0. So when you plug in 0, start with the 0, so you get negative 1 raised to the power 0 x to the power 0. That is the first one, which is negative 1 raised to 0 is 1, because anything raised to power 0 is 1, and x raised to 0 is 1, so we get 1. Then when I plug in next value of n, which is 1, we get negative 1 raised to 1, and x in place of x I will have x raised to 1. So I will get negative x, and so it means our power is correct. Now if the summation sign was starting at 1, if we had something like this, then you see the first value of n can take is 1, and if you plug that in, you get a negative first term. So if the first term is not negative, then you have to adjust the power on the negative one. Okay, this was not part of the solution. So this is how you get the series for 1 over 1 plus x. Let's look at one more example, then I will give a break. Okay, 1 over 1 plus x squared. Again, now this is, if you compare, what is here? A is 1, the first term is 1, and then what is r? R here is not x squared. Remember, we have to have a negative sign here in the middle. So r will be negative x squared. So how will you get the power series for this function, 1 over 1 plus x squared? Well, you have to plug in negative x squared in place of x. in the expansion or in the power series of 1 over 1 minus x. So let's do this. This is equal to, so remember the closed form of that series was x to the n. But now in place of x, I will plug in x2. So x square, negative x square, sorry, negative x square whole raised to the power n. So this is the closed form. Now let's look at the expanded form, and n goes from 0 to infinity. So this can be written as summation negative 1 raised to the power n into x raised to the power 2n. So this will give me n goes from 0 to infinity. So the first n is 0, will give me 1. When n is 1, I'll get a negative sign, and then I get x squared. Then we will have a positive, and the power number value for n is 2. So when n is 2, we have a positive sign from here, from the negative 1, and then x raised to the power 4 plus 2n means 2 into 2 now, 4. What do you think will be the next term? Once we have to now plug in 3. So cube, negative 1 cube is negative 1. So negative. And what is the power on x? X raised to the power 2 into 3, which is 6. So you get series like this, with all the x's are with even powers. Next term will be plus x to the 8 minus x to the 10 and so on. So this is the power series for 1 over 1 plus x squared.